If you want to take out your highlighter on the next page, we can highlight some definitions. So a geometric sequence is formed by multiplying each time. So they've got an example of a sequence right here, 4, 12, 36, 108. The first term is 4, and we're multiplying each time by 3. In arithmetic sequences, we were adding by the same thing, and we called what we were adding a common difference, and we use the letter D. In geometric sequences, when we're multiplying each time, we call it common ratio, and we use the letter R. So in this case, right here, we would say that R is equal to 3 because we're multiplying by 3 each time. How do you find the common ratio if you can't tell just by looking at it? Like this one, can you tell you're multiplying by 3? Yes? What if I gave you, let's see, what would be a, all right. Looking at that one, can you tell what I multiplied by? 1.3? Close. 1.4? Farther. So now you're just guessing, right? So how do we find out the common ratio? Well, we can find it by taking any two terms, and it doesn't matter which two, and dividing them. So you could do term 2 divided by term 1. 12 divided by 4 is 3. Here, 36 divided by 12 is 3. 108 divided by 36 is 3. So if you take 6.15 and divide by 5, you get 1.23. And if you take 7.5645 and divide it by 6.15, you get 1.23. So you can find your common ratio by taking any two consecutive terms and dividing them. Sometimes a question will ask, is this a geometric sequence? Then you would have to check them all to make sure you're always multiplying by the same thing, that the common ratio is the same all the way through. A sequence that continues forever. If it has that dot, dot, dot on it, we call it an infinite geometric sequence. And if it ends, if there's only a certain number of them, we call it a finite. So infinite goes on forever, finite has an end. You don't have this picture in your notes, right? Okay, so we'll just ignore it. If you have a sequence that just keeps getting bigger and bigger and bigger and bigger, which would happen if you keep multiplying by 5, the numbers just keep getting bigger and bigger and bigger, we call that sequence divergent, because it keeps getting bigger and bigger. If, however, you have a sequence that, I think this is the next example, you do have these numbers, 1 over 2, 1 over 4, 1 over 8. If we're multiplying by a half each time, we would say that sequence is convergent, because as you go further and further along, your numbers are getting closer and closer to something. In this case, they're getting closer and closer to 0. So if it's getting closer to a value, we call it convergent. If they're just getting bigger and bigger and bigger, we call it divergent.